Okay, so on example number 1, it says this. Tell whether x and y show direct variation, inverse variation, or neither. All right, so look at example number 1. All you have to do on example number 1 is get the y by itself. What would you do to get the y by itself here? Divide by x, right. Divide by x, divide by x. Okay, so what do you get? You get y equals 7 over x, right? Okay, now look at that and look at the forms up here at the top of the page. Which kind of variation is this? Okay, this is inverse, and you would write down the word inverse. This is inverse variation. Very good. That's how easy this is. Okay, so that's example number 1. Okay, now look at example number 2. Y equals x plus 3. Okay, what do you have to do to get y by itself? It's already by itself. You don't have to do anything. So now compare that with what you have at the top of the page. Well, okay, very good. That's neither. That's not inverse. That's not direct. That is a neither. You got it. So that's neither. Okay. All right, now go to C. Y equals, y over 4 equals x. So what do you have to do to get the y by itself? Multiply by 4, exactly. So multiply this by 4, multiply this by 4. The 4's cancel, right? You get y equals 4x. Okay, now look at the top. Which one is this? This is direct variation. That's how easy this is. All right, so everybody lost how to do the first part. Okay, so easy, easy. Okay, let's go to the second part of this now. Okay, so here's part 2 now. Okay, now on these, it's telling you this. The variable x and y vary inversely. So they're telling you this is inverse variation. They vary inversely. Okay, and y equals 7 when x equals 4. So you've got to do 2 things. Write the equation for this, and then number 2, tell me what y will equal when x is negative 2. Okay, so here's how you're going to do this. The first thing you're going to do is write y equals a over x. That's your first thing, because that's the inverse equation. Okay, now you're going to go take the value. So look, y is 7 and x is 4. So you're going to put 7 in for y and 4 in for x. Okay, then you got to get a by itself. What do you have to do to get a by itself? Multiply both sides by 4, right? So you're going to multiply this by 4, and you're going to multiply this by 4, right? Okay, so then you're going to find out. Let me move this up a little bit because we're running out of room. Okay, so you find out what? That a equals how much now? A is 28, okay? All right, so now, once you find out what the a is, you can write the equation. The equation will be what? Y equals 28 over x. You got it. All right, so there's the first answer. That's the equation. There's the answer. Okay, now we go to part 2. Find the value of y when x equals negative 2. So all you're going to do is what? Take the negative 2 and put it in for the x. Very good. So you're going to go like this. Y equals 28 over x. And then put the negative 2 in for the x. Like this, right? So how much will the y equal? Negative 14. There you go. And there's the answer to part 2. Okay, so that's how you do example number 2. Okay, so for example 4, we're going to go to example 4 first. We'll go back to 3 in a second. Okay, for example 4, let's go to part B first. Okay, so now, let's do this. Okay, how much is 1 times 12? 12. How much is 2 times 6? 12. How much is 3 times 4? 12. How much is 4 times 3? 12. So do those all equal each other? Yes. Okay, now if that's the case, what you just found out is this, okay? What you found out is that, look, these two multiplied together equal A. Therefore, what kind of variation do you have? Inverse. This would be an inverse. Very good. It's correct. And so you're going to write the word inverse here. And that's what it says on the notes. Okay, so now let's go to C. Okay, how much is 1 times 3? 3. How much is 2 times 6? 12. How much is 3 times 9? 27. How much is 4 times 12? 48. Okay, right. Do those equal each other? No, so that means it's not inverse. It's not inverse. Okay, all right. Let's get that out of the way. Okay, how much is 3 divided by 1? 3. How much is 6 divided by 2? 3. How much is 9 divided by 3? 3. How much is 12 divided by 4? 3. Okay, do those equal each other? Yes, so that means that it's going to be correct. So this is a correct, right? That's all you have to do. So there's that. Okay, now let's go to A. A is next. Okay, how much is 1 times 4? How much is 2 times 5? 10. 3 times 6, 18. 4 times 7, 28. Okay, so let me ask you this. Is it inverse? It's not inverse. Okay, so let's get rid of that. Okay, how much is 4 divided by 1? 4. 5 divided by 2? 2.5, or 5 halves, right. 6 divided by 3? 2. 7 divided by 4? 1.75. Okay, do those equal each other? No, okay, so it's not correct. Okay, so what's the answer going to be to this? This is a neither, right. It doesn't equal either of them. This is a neither. Okay, so there's that, all right? Put that on. Okay. All right, so the first question is this. Write a model that gives C as a function of A. Okay, so here we go. How much is 448 times 58? What you guys get? 25,984. Okay, let's do the next one. How much is 424 times 62? What you guys get? 26,288, right? Okay, all right. How much is 376 times 70? Okay, you getting that? 26,320? Okay, how much is 392? I just went out of order, didn't I? I just realized that. 392 times 66. Just went out of order. It's okay. Same difference. All right, and what'd you get? 25,872, right? All right, so everybody getting those numbers, right? Okay, now here comes the thing. Now listen carefully, because it's everyday real life problem. Are these numbers equal to each other? No, but here's the thing, because it's everyday real life. Are these numbers close to each other? Yes, okay, so here goes the thing. All these numbers are close to what number? About what? About 26,000 is right. They're all in the vicinity of this number. 26,000. So the thing is this. That's what your A value is going to be, about 26,000. Okay? All right, now your job is to write a model that gives C as a function of A. Okay? So here we go. C equals what now? What does C equal? 26,000 over A. Over A. 26,000 over A. Very good. There's the answer right there. Okay, because once again, it says this. Write a model that gives C, right? Okay, which is the number of chips over A, the area in square millimeters. Okay, so instead of using X and Y, you're using C and A, right? Same thing though. Okay, so that's the first part. Okay, now we go to part 2. Predict the number of chips per wafer when the area of the chips is, and it's got 81. Okay, it's 81. Okay, millimeters squared. Didn't do that. Okay, so what are you going to do here? That's right. Okay, very good. That's right. Okay, so you're going to say C equals 26,000 divided by 81. Okay, now you guys go to your calculators. Okay, and you're going to round the answer right to the nearest full number. So it's about how much? Say again. 321 is right. You got it. It's about 321 chips is what you get. There you go. And there's the answer for the C. Okay, and that's how you do it.